Hello you lovely people and welcome. In this video I'll be doing a demonstration of the automatic flying control system, navigation and INS. I'll be flying the FGR2 version of the Phantom from RAF Coningsby, so I'll be conducting all of the flying around this area and you'll see why as I come nearer to the end of the video. So let's jump in the cockpit. For all my demonstrations in this video I'll be flying XV574 of 111 Squadron RAF, formerly RAF Lucas, and nicknamed Tremblers. Fantastic livery and available on flightsim.to. Thoroughly recommend adding it to your collection if you are a PC user. Right, before we get into the air, just a quick instrumentation call out for the demonstrations. That'll be the main AFCS control panel here, including the Stability Augmentation System, or SAS, pitch roll yaw, coupler, AFCS master switch and altitude hold. That'll be used in conjunction with the navigation master mode rotary knob here, and we'll be going through the different modes as we go along. That'll be used in conjunction with the HSI, ADI and the radar scope. And speaking of radar scope, we'll stick that into map mode and put it into mid-range, as is my usual way of doing things. Now I'm going to get up in the air. Once in the air, we'll start with ATT, which is attitude. Right, so we're in the air, we're cruising along quite nicely here. What I'm going to do is pull up. I'm going to go to about 10 degrees nose high, keep it nice and shallow, stick on AFCS, coupler and pitch. As you can see, it's holding my attitude, and I can change that at any time. So if I take pitch off and AFC off, pull up a little bit higher, should hold. AFC on and pitch. Okay, and what you'll notice is that the glide slope indicator here will raise and lower. As you can see, it's quite high on the, it's not central, which means the nose is climbing, and we are now going 30 degrees nose high and climbing still. And there you go, it's holding at 30 degrees. Now, just to show you that it will still hold that no matter what, I'm going to throttle back. Let's throttle back up again, get out of the stall. And you see it goes back up to 30. And we can throttle up, and we can throttle down, and no matter what, if it loses if we stall completely, as you can see, I'm slowing down, slowing down, slowing down, still trying to hold it, and now we're stalling. Let's throttle up again, get that speed up. Okay, we're in burners just to get the nose back up again, and I haven't touched the control column at all. Okay, and we're holding. Right, next is heading. So the aircraft's nice and settled now. I'm going to stick our nav mode into heading. I'm going to switch on coupler, pitch, yaw, AFCS. This will now hold the aircraft on our current heading and stop us from drifting. As simple as that. If we switch on the altitude hold as well, there we go. I mean, we can still turn. If we're looking for targets, we haven't got to worry about the nose dropping. We can roll over, check the ground for any targets that we're after without worrying about the systems at all. So that's heading. Quite basic really, and simplistic, and well, does what it says. So yeah, that's in conjunction with coupler, AFCS, altitude hold, yaw and pitch, and it will hold your heading without drift. So next we have heading heading selected. Now if I switch all of this off and we press and hold the left mouse button and click the right, get the heading bug where we are, and if we do pretty much what we did before, but if we switch absolutely everything on, make sure the aircraft is settled before we start moving it left and right. Okay, altitude settled. Now when we turn this rotary knob here, the aircraft will turn where we want it to. So say we want to turn to 150. Quite simple. Turn the heading bug to 150. Chugging away there, don't know what's happening. So you can either hold and drag, or you can use the mouse wheel. And now we will turn to 150. There we go. Start to level out. Okay, and we're still slowly leveling out to 150. So that's heading selected. That uses all the switches on the AFCS, obviously in heading selected mode, and then using the heading bug to turn where you want to turn to. Okay, switch that off. Next is TACAN, and for that we're going to need the TACAN channel. I believe, if I remember rightly, it's 48 X-ray for Coningsby. I'm going to select TACAN there. You can see that's moved off. We can now move the course needle, and this will point to where we need to go. Now we can either do it manually, so that we've got, there you go, 0045, we're 47 nautical miles away, so we can either turn to that manually, or if we really want to and we want to be lazy, we can stick on all of our couplers there, pitch, and the aircraft will automatically turn towards the TACAN. Just to show you that the aircraft will do that itself. I prefer to do it manually, but you have the ability to do it automatically anyway. You should see a TACAN symbol pop up if we haven't gone too far away from Coningsby. It's up here somewhere. There it is, I believe. So we should head, that line should line up with that TACAN there. I could be wrong, that could be it there actually. I am wrong, it's that one. That might be Waddington. Let's have a quick look out the window. A bit too far away still, I think. Pretty sure that's Waddington though. So yeah, as you can see, we're head on with the TACAN symbol there. And you can see we've got, these are obviously airports, but some have TACAN, and it shows up on the map. So that's TACAN using TACAN channel, TACAN in the nav mode, using the HSI, and everything in the AFCS. Okay. And next is nav mode. For that we need a flight plan. So I'm going to back out of this, just do a quick flight plan, show you that flight plan, then get back in the aircraft. So I've made the most simplistic flight plan I possibly can, going from Coningsby, Waddington, Scampton, Burwell, then off to Croft, and then back in to Coningsby. So there you go, simple. I'm going to load that into the aircraft now. Let's get the aircraft set up for the flight plan. So the first thing I'm going to do is radar scope. I'm going to switch that to map. As you can see, we have the flight plan on the radar scope. I'm going to rotate this knob to nav. Okay, and you're not going to be able to turn the course needle. You can change the heading bug if you're going to be using AFCS without following the flight plan. Not that you're going to need that anyway, because it will just automatically follow it anyway. And we're going to be using all of these switches here to get around the circuit. So let's take off. What I'll do is I'll take off, settle around about 2,000 feet, and then I'll get everything all switched on automatically and let it do what it's got to do. So, parking brake off, toe brakes on, throttling up, through the gate, reheat, brakes off. Okay, over 150 knots now, rotate, gear up, flaps up, climb to 2,000 feet. Okay, gone slightly over. Come out of reheat. Don't want to be going too fast. Engage altitude hold. Let go. And the aircraft will chase the flight plan. First port of call will be Waddington. And there's Lincoln Cathedral over there. Waddington is on the nose now. You can do all this manually. I'm just doing it with the AFCS at the moment just to make my life a bit easier on the video. So we have Waddington just here. Okay, now you can see that we've changed to our next waypoint, Scampton. So the aircraft will now turn towards Scampton. There's Lincoln Cathedral. Scampton is over here somewhere, I believe. Not too far away. Just the other side of Lincoln City. Just there, that's Scampton, home of the Dam Busters. Okay, and that will change any moment now. And there we go, we're going to chase the flight plan to Burwell. Speed down. Actually, no, I won't. We'll bring the speed down. It will make the flight longer. So Burwell is on the nose now. Because we're trying to chase the flight plan, it's overcompensating to get on the flight plan. Once it gets closer, we'll bank left and get Burwell back on the nose. Just going to look for the localizer bar here. We'll drift off to the left slightly. As you can see, it's not completely central, meaning that the aircraft is banking slightly. You can also tell by the artificial horizon, but this line tells you that the AFCS, what it's doing at the time. If it's climbing, the bar will rise. If it's descending, it will get lower. If it turns left or right, it will be left or right with the centre line, letting you know that the flight computer is doing exactly that. Okay, so there you go, it's moved over even more, and getting Burwell back on the nose now. Let's slow it down slightly. And that will change in a moment. There we go. And now we will go to, I forget the name of our last waypoint before Coningsby again. Croft, I believe, Croft Airstrip, which is this one here. Still going too quick. Okay, that will change any moment now, and we'll head towards Coningsby. There we go. There's Coningsby there. Okay, we can stick the gear down now for a long finals. Bring the flaps down slightly. Take it out of automatic flying controls, and now we can use the radar scope, and we can also use our HSI here as an indicator of where the airfield is, because we won't be able to see on approach. Trim out. Okay, so that was nav mode using a flight plan, and we're back down at Coningsby. God, it wasn't the best approach, but you got the idea. Next is VOR. There's two versions, VOR and VOR2, which means you can choose between the two as you're flying. I'll just show you the one because it's the same process over again. So let's reset and do that quickly. So you want to chase VORs? I've got you covered. Come down here to nav master mode, rotate it clockwise to VOR. You've got VOR2 as well. So this will be the same process for both. So I'm just going to show you VOR in this section. You can turn the course needle and the heading bug. So if you want to chase the VORs manually, you can do. We're going to use the Gamston VOR. We're going to be using our trusty nav radio here. So we want 112 800. Okay. Now we won't pick a signal up until we get up in the air. And again, you can use all of these in conjunction with the VOR, and it should fly you to the VOR automatically. So let's get up in the air. Same process as usual. Parking brake off, tow brakes on, all the way up to the gate, through the gate, reheat, tow brakes off. .150 knots, rotate, gear up, flaps up. Trim out. Now what I am going to do is going to put altitude hold engage on. And AFCS coupler, all of those on. Oops. And as you can see, the aircraft is now moving towards the VOR. Now if I turn the course needle so that CDI is central, okay, and you can tell we're on the VOR. You can hear the Morse code in the background. Now you've got many ways of chasing the VOR in this automatically. You can do it with all the switches on, or you can change it so that you're just chasing the heading bug. And if we do that, put the heading bug forward, switch off pitch. Pretty sure that we can do that in this mode. Actually no, I don't think we can. You can't do it manually that way, but you can disengage everything. Keep the altitude hold on. Make sure all these three are on, and you can still fly the aircraft as you wish. using the ADI, sorry, HSI to get you on the right path. So let's get that turn tuned into the right direction. And as you can see, I'm manually doing this, which is how I would normally do it. Okay, we'll level out. Okay, and now we're heading towards Gamston, but I'll flick all of these back on, get it all automatic, slightly off. Okay, now we're heading towards Gamston. Shouldn't take us long. We are 7 nautical miles away, and we get DME, which is good. And that's it there, I believe. Once we get over the top, we'll be flying from the VOR. So the white triangle will then head in this direction with an empty triangle to let us know that we are going away from it. So if I disengage those so that it doesn't try and turn around and come back towards the VOR, and also the course needle will swing. The needle did not swing, I was wrong there. So there you go, we have an empty triangle to let us know that we are now past VOR. So if we engage these all again, the aircraft will now try and turn around and head back towards it, because we have that VOR plumbed in. Change it now so that we have a full triangle. There you go. Slow it down as well so we can get a tighter turn radius. We're only 6 nautical miles away, so not too far. I believe this is Gamston just here, and there it is there. Nice and simple. So you can either do that manually or you can use it with AFCS. Entirely up to you, but there's plenty of choice. You can mix it up, do what you want, whatever makes you feel comfortable. Now the last bit is going to be the most awkward one of them all, because this really screwed me over yesterday, because for some reason I couldn't remember simple geography. So I'm going to break it down for anybody, just to make it easy, and that's using the INS in the back seat to get from point A to point B. So we'll get on the ground and we'll reset, get back on the ground, and we'll jump in the back seat. Right, so before we can use the INS in the Phantom, we need some coordinates converted to decimal. Me being as thick as anything, I can't do conversions. I'm absolutely rubbish at maths. So this website helps me. I've used this previously for the SimSkunkWorks TF104G. It uses a position and homing indicator in the cockpit to basically use waypoints, and to make those waypoints on that aircraft I had to get my coordinates and decimal write the decimal down and put it into the file that I made for that aircraft. This is going to be pretty much similar for the Phantom, except we're not creating files, we're just writing down the decimal. And now this is good because this website gives you a map of the whole planet. It shows military airfields and places in the UK if you're using that. I believe it would do the same for the US and maybe other parts of the planet. But the main thing is it gives you coordinates for anywhere on the planet. You can do that on the flight planning section on the sim, but when it comes to conversion, unless you can do it yourself, on this website you can't manually input the coordinates. It will take them straight off the map here. So if we zoom into the UK, go to RAF Coningsby, and I'm going to choose here as our starting point. And this is what threw me the other day. I automatically assumed that RAF Coningsby, being on the east coast, would be an easting longitude, and it was a westing, and it completely threw me and I couldn't work it out, and I'm not joking, it took me a whole afternoon to figure out where I was going wrong. And it was like unlocking a chest. Once the lock was open, all the information come flooding out, and I realised what an idiot I'd been. So yeah, here we have our coordinates, degrees, minutes and seconds, but we're not going to be using these. If you put these into the INS, you will not have the flight plan where you want it. It needs to be converted into decimal. And then there's another process we need to do for longitude. So latitude we can write down, no problems whatsoever. 53 decimal 0.89356. Okay. Longitude, it's a westing, so it's minus. We need to remember that. And then what we're going to do, as this is a single zero, and it shouldn't be, it should be 3 zeros, because you can go up to 360 degrees in the bearing compass. So that should be 3 zeros. So you should always remember that before the decimal it should always be 3 digits. But what we're going to do is take off the last one and add an extra zero of what would normally be 2 zeros or 3 zeros if we're doing anywhere up to 360. So that is 3 zeros. We're going to take that off, take that 4 off. So for the westing, we're going to put 0, 0, 0, decimal 18550, and like I said, we're just going to leave that 4 off. I'll go through the process again here. I'm going to go to the bombing range at RAF Holbeach, and there is a barge, I believe, sure it's here or here, but we'll choose the middle ground. Actually no, we'll choose here. Right, there are our coordinates, our degrees, minutes and seconds, and that's converted to decimal. But as you can see, we don't have a minus on this one. That's because it's an east, and you can see that it says E there for easting. Again, we're going to do the same. We're going to add 2 zeros to that and take off the 8 at the end. Trust me, if you don't, you're going to not have a flight plan where you want it. So latitude, again, we can write that down as normal, 52. We don't really need a decimal, but I put it in anyway. 877107. Now longitude, again, 0, 0, 0, decimal 16874. Cross off the 8, forget that. Now just to show you a different one, if we go somewhere else. So there we go. We've got just as a an example. Again, if we were going to put this into our INS on the Phantom, we put the latitude in as normal, nothing changes. For the longitude, we would add 2 zeros to that, then the 3, decimal 95231, get rid of the 7. So you always add an extra digit, or 2 extra digits, depending on where you are on the planet. So say if you had a 4-3 there, you'd still add a 0. As long as there's 3 digits before the decimal, you're good. If they don't show, they're automatically assumed as zeros, otherwise they would be there. So if I can find somewhere a bit, there we go. So we've got 12 here, 12 decimal, we'd add a 0 to that and get rid of the 8. And if we really wanted to go mental, because it goes to 180 either side of the meridian line, so we can get anywhere up to 180 on here. Right, let's cross over. So there we go, we've got 101. We wouldn't add anything to that, we'd go 101 decimal 88446 and not take the 0. Okay, so there's always three digits before the decimal. If there isn't any digits in front and there's only shown 1 or 2, then you automatically add a 0 to it. Okay, so I'm going to take the coordinates, or the decimals that I've just picked up, and we're going to go and put them in the Phantom. So before we jump in the front seat, we're going to put the radar scope to map. We're going to put mid-range as normal for me, and then just as a call out for the instrumentation we're going to be using, obviously all of the AFCS panel there. I'm going to switch this over to nav mode. Okay, now we're going to jump in the back seat and put in our decimals. Right, so we're going to come down to our INS. I'm going to click this to standby, must be in standby, and then we're going to stick in our coordinates. But as you can see, our starting coordinates are already in here, but I'm going to change them anyway to the ones that I picked out, because it will show up on the radar scope, because I've chose the other end of the runway, so we should see it. So as you can see, already on the westing, that will change to east, so we'll start off here. Now each time you move it, we'll move the first 2 digits. To get to the next set, you need to hold the left mouse button down, click the right, and it will move to the next set of digits, two digits, and then again for the next 2, again for the next 2, and then if you do it again, it will take you back to the first 2. So if we sort out 53 decimal 08 93 56. Okay, I'm going to come down to the bottom. As you can see, it's already got 3 zeros in, like I said previously. If we change that, it will go to easting. So left click and right click to move it over. 01 is already put in. Come over to the next set, which is the 46. We'll change that to 85, and we scroll down for the numbers to go up in westing mode. 85, left click hold, right click, and then we're going to come up to 50, so we scroll up to get the numbers to go down in westing. Right, now we're going to put our target coordinate in. So Northing is 5-2, so 5-2, hold left click, right click, it's going to be 8-7. Hold and click again, 7-1. Next section, 0-7. Okay, and now we're going to come down and change that to easting, so 3 zeros already there. And we are going to change it to 00016. So 1, 6, 8, 7, 4. And we're scrolling up for the numbers to go up this time because we're in easting. 7, 4. Okay, and now we switch over to OPR, which is operating. And there we go, we have a flight plan. So that's the end of the runway, and if we zoom out a little bit more, sorry, you can see that there's the wash, and that's Hull Beach there. So I'm just going to fly that quickly. Just jump back into the front seat. Alright, let's get rolling. Parking brake off, toe brakes on, throttle up. Through the gate, reheat, brakes off. Through 150, rotate, gear up, flaps up, some speed up, trim out. As we're in nav mode, switch everything on, hold the altitude, coupler on your roll pitch, and can come out reheat. Now a little bit of a problem that I've encountered before is that sometimes when you get into this it will send you in the wrong direction. So what I do is, what did I do last time? I switched the, if we go back into the back seat, and switch off into standby, go back into operative again, and it will change it to the flight plan that we're supposed to be getting. Okay, so we can go back into the front seat. You'll see now that the course arrow is now pointing in the right direction, and the flight computer is flying the proper flight plan. So I'm just going to speed it up from here until we get to our target. And we're coming up to Hull Beach bombing range now. As you can see, the barge is just off there. I wasn't too far out, thank God. We can set our depression. Mine's severe. So yeah, there's the barge I was aiming for. This is the Hull Beach bombing range. And yeah, there's one bombing circle, there'll be another one here, and a strafing pit across there. So yeah, there you go, INS. we managed to convert everything, input it, and flew the route. So there you go. Hopefully all of that has helped. I'm sorry the INS can be a bit confusing, and if I didn't explain it very well, again, I do apologise about that. But it's still quite difficult for me to do without the help of that website. So again, if you got this far, thank you very much. Thank you to CJ and DC from DC Designs for their patience of me asking stupid, ridiculous questions over and over again. And thank you all for all your support and following me and subscribing. So I'll end it here. Take care, and I'll see you in the next one.